In order to get a 2D image like this one to appear on a 3D model, we have to tell Blender which part of the image should appear on which part of the model. This is a process we call mapping, and there are a couple different methods of doing it. The first is called UV mapping, which is where we directly assign faces to a location on this image. That's so common that it's what Blender assumes you want to do when you add an image to the material in the shader editor. So let's go ahead and add this in. I've created this image to be just a grid with a couple gradients. Gradient going from dark to light, bottom to top, and one going from saturated on the right to unsaturated on the left. The reason that this makes a good test image is that we can always tell when we apply this to our object which part of the object is getting which part of the image. Okay, so let's close that out, and I'll hit Shift A, go to Texture and Image Texture. I'm using the shader totem start.blend if you want to follow along. I've also included the texture in the textures folder of the downloads. Let's go ahead and click Open, navigate to the textures, and click Grid Blue JPEG. And then we can plug this into the base color. Okay, so we can see that it's been applied to most of our objects, but not this one here in the middle. This is the classic shader orb from the Shader Forge series, and it was created by Kent Trammell. And of course, he did create UVs for it, which is where you assign faces to different parts of the image. But in this case, I actually deleted them because I wanted to use this as an example of a couple different ways of mapping. So it's going to assume those UVs by default, and it's being plugged into this vector slot here. In the Fundamentals of Materials and Shading course, we talked about this vector input here at the bottom of every texture node, and it's like directions. That's what's telling a texture where to go on the model. But right now nothing's being plugged in, though not explicitly. It's being plugged in under the hood for us. So let's just make that explicit here by adding a texture coordinate node. Shift A, Input, and Texture Coordinate. If we plug in UV here, then we're not going to see any difference because that's already what it's doing behind the scenes. So a texture coordinate is just a set of directions that's telling this texture where to go. But of course we can change those directions if we want. And we can do that with a mapping node. So let's go to Shift A, Vector, because we're working with vectors, and Mapping. Drag and drop that right in, and we won't see any difference until we start changing around the location and rotation. So we can change the location here, or the rotation. And not all of these transformations are going to immediately make sense until we start digging into UVs later on in the course. So I'm going to reset this by hovering over these inputs and hitting backspace. And then let's take a look at these other texture coordinates that we can use instead of UVs. First, I'll start with generated and plug this into the vector slot here. And if we look at this from top view, I'll hit 7 on my number pad. You can see that this texture has been projected perfectly onto our models. It's as if there's a light from above shining down with the texture applied to it, and it just works great. However, if we look at this from the side, then things start to get very stretched. So it's almost exactly as if a projector had just shined through the top and just beams straight through the whole object. We can change the projection method though if we want, and change that from flat to box. This is a technique called box mapping or triplanar mapping, depending on what software you're used to using. So, as you can imagine, box mapping works great for a box, but for more complex objects, then it doesn't quite work. Well, actually it works great, but you're going to get these seams. So this is totally fine if you're just using like a gravel texture or a grass texture that's pretty repetitive everywhere and there aren't obvious seams, then that's fine. You can just use this blend value and just kind of blur those lines a little bit and blend those together, and that works great. So for simple things like that, then this is an excellent option, and you don't have to have UVs, and it works with every object, regardless of how much geometry it has or whether it's messy topology or whatever, it's always just going to work. The downside though is of course that we can't get very specific about where those seams are or where each part of the texture appears on the model. The next most similar texture coordinate to generated is object. So let's plug that into the mapping node here, pass that through, and I'll set the blend all the way down to 0, just so that we can see this better. This is similar to generated, but instead of starting all the way from the left side, it starts in the middle of the object and just keeps going. We can actually better see how these texture coordinates are working and what directions they're giving to our image if we break it down a little bit. I'm going to be using an add-on called Node Wrangler, and it's almost a meme at this point to enable Node Wrangler in a tutorial, but I want to show you here just to make sure, because this is a beginner course. So let's go to Edit and Preferences, and if you don't have this enabled, just type in Node and check that on. It comes included with Blender. Click Save Preferences, and you'll probably want to have that on pretty much all the time, anytime you're texturing in Blender. Okay, so with that, we can hit Control and Shift. That gives us a new hotkey, and we can look directly at these texture coordinates and see a very colorful display. So all these colors represent the different axes, the X, Y, and Z axes. And we can see that more explicitly if we separate them out. So let's use another node. This one's going to be a converter, and we're going to separate X, Y, Z. We're going to take this X, Y, Z information and just separate it out. So here we can see the X axis starts at 0 on the left and goes to 1 on the right. Then we have Y, and we have our Z axis. So these values are all normalized within the bounds of the object. Nothing here is negative or over a value of 1. If we plug an object, though, instead of starting at the bottom of the object itself, it'll start at the object origin, and then pure white, which is 1, is going to be 1 unit above the object origin, and then a value of -1 will be 1 unit below the object origin. So that's why when we plugged this in, the texture appeared to be really, really big. If we wanted to, we can manipulate all the different axes like this, and then combine it back together. So let's say we just want to squish this along the Z axis. Well, we have our Z here, and we can use a math node. Converter and math. I'll plug this right in. And I'll hold Shift and just drag this value here. We can drag it up and down. See exactly what's going on. But if we wanted to squish it together, then we could use a multiply node. So I'll switch the function to multiply. And if we multiply this by a big number, it's just going to squish that farther and farther down. You can see if we go to a negative value, then it'll flip it. I know I'm getting a bit in the weeds here, but hang on. Here's a more visual example of what we're doing. This gradient represents the Z-axis of the coordinates. If we add a value to every point along the gradient, we end up shifting the gradient down. If we subtract, we move the gradient up. Numbers can be negative or more than 1, it's just that we can't display that with colors. Now if we multiply, we squish or scale the gradient. You may never have to do the math, so it's not that important. But what is important is that you understand that the coordinates are X, Y, Z directions, and that you can manipulate those coordinates however you want before they get plugged into the texture by using a mapping node or math nodes. Okay, so let's multiply this by 5. And then let's combine these axes together. Shift A, converter, and combine X, Y, Z. Plug the X to the X. We can see here that that's just red. If we don't have anything plugged in, then it's completely black, but the X is going to add that red color. The Y is going to add the green color. And then the Z is going to add the blue color. But since we multiplied this, we kind of squished it along that Z axis. So that's going to essentially just scale it along that Z. So now if we look at this texture, it's now squished along the Z axis. As we change this number, it's going to change how much it's squished like that. If we wanted to shift this around, then we could use an add instead of a multiply. So let's hit Shift A, converter, and math. This time we'll just use an add, and then as we change this around, it's going to just shift it. We could also use a subtract if you wanted. That'll do the same thing, just in the opposite direction. Okay, so we don't need to do all that. That's a little bit overcomplicated here, especially for a beginner tutorial. I would not worry about doing anything like this until much, much later. However, I wanted to show you how it all works, just if you're curious, because that's going to help explain just how this stuff is working under the hood. The most important thing to know, though, is just that you can use generated and object coordinates to get nice box mapping. The nice thing about using objects instead of generated is it's going to try to keep the scale of the texture consistent across all of our different objects. So let's use this mapping node to, let's say we increase the scale here just so we can see more of our checkerboard pattern. And let's say we scale up our sphere to be really, really big. Well, now the checkerboard on the sphere is going to be a lot bigger than the checkerboard over here on the cylinder, and so they don't quite match. If we were to apply our scale though, we can see in our object properties that our scale is about 4. If we hit Control A, so that the scale is applied to the vertices themselves and not the object, then everything's now going to match. Now everything is exactly the same size, and we can line things up if we want. I'll hit Control Z and undo that. Or actually before that, I'll just plug in generated here to show that it's not going to make a difference. So with generated, things will not be consistent if things are different sizes. But I'll hit Control Z and undo that, make the sphere small again. And in fact, this is such a common thing that Node Wrangler has a hotkey to just do the setup for you. So I'm going to go ahead and just delete these 2 nodes here. And you do have to set it to box manually, but if you hit Control T, that's going to add a texture coordinate and a mapping node for you, no matter what node you have selected. So that's very, very handy. And then you can just plug in generated and you're good to go. Now there are a couple different projection types that you can use besides box. You can use sphere, which is really great for, of course, a sphere, but it's going to stretch on our cylinder here. You can see that the squares are really, really big near the edges, stretched near the middle. And it actually works pretty well on the top here as it just radiates out from the center. But for most complex objects, this one looks pretty weird. You can see on the cube, it distorts pretty heavily towards the center there. And so it's not one that I'd use hardly ever, except for just actual spheres. The next we have tube mapping, which again is pretty specific to like curves or tubes. This one I use for if I'm like manipulating curves, then it's a good one for that. But it doesn't project to the top or anything like that. So I just usually stick to box mapping. But now I want to look at the other texture coordinates that we have available just to briefly run through them, even though this one's the one you're going to want to use most often. Let's switch this back to flat and hit Control X to get rid of our mapping node. And Control X is different than X because X will get rid of the node completely, while Control X will delete the node but keep the connection. Okay, so let's look at the next one down. So we looked at generated, we didn't look at normal, but I'll bring that one up at the end. UV was the one we started out with. We looked at object already. Camera just projects the texture from the viewport itself or whatever camera you're looking at it from. And it's slightly distorted by the shape of the geometry. And this can be useful for some things. Again, probably not something you'll need until much, much later in your Blender adventures. Window is very similar to that, but it just looks straight through. And it also uses the dimensions of the viewport or dimensions of the camera. So as I stretch my viewport, it's going to kind of squash and stretch that texture. So it's useful for very specific things, not one you're going to be using too often. Reflection is kind of cool, and you can use this to just make it look as if the texture is being reflected by the object. Not really useful with a flat image texture, but you can use this with an environment texture to like reflect fake environments. So if I hit Shift A, texture and environment texture, I can open up our workshop HDR, which is what we're using here in the background. Plug this reflection coordinate into the vector and hit Control and Shift and look at this texture. You can see it looks as if it's, reflecting this environment, similar as if we had like a really shiny object. But this is actually just a color. We could plug this into the base color of our principled BSDF here. And it looks like it's very, very shiny, but the roughness is actually all the way up at 1. So you can do some really trippy lighting effects with this and get really fancy if you want. But it's, again, something that's pretty specialized and not something I use very often. The other one is normal, and again, a pretty specialized one. It's going to just stick it to the surface based on the direction that the face is pointing. But it's not really useful for geometry or that useful for geometry, but it's extremely useful for lights. So I talked about this briefly in the lighting course as well, but just as a recap, you can only use nodes for lights if you're using cycles. So I'll briefly switch over to cycles here, turn off all of my lights in my outliner, and I'll turn off my HDRI in the world tab as well, just so we have a completely black scene here. And then I'll hit Shift A, go to light, and I'll add a spotlight. So it's shining down. Let's see that here. Okay, and then if I click use nodes, again, this only works in cycles at the moment, unfortunately. But I can add that image texture, Shift A, texture, and image, or even before that, I can just hit Control T on the emission, and that'll add the whole setup here for me. I'll use that grid blue. And of course, any of these texture coordinates, generated, UV, isn't going to apply that image to the light, but normal will. So this is the one that works with lights, and it's going to be very, very fuzzy because we have a large light, and so it's going to be very soft. It's going to cast soft shadows. But if I decrease the radius here all the way down to 0, then we'll get a nice sharp image. So now we can cast this texture wherever we want. We can change the mapping here. We can change the location. There we go. And we can just project this around. Interestingly, we can also use, I believe it's reflection here, to do a similar thing. But this one's going to try to stay put in the world. So wherever I move my light around, it's going to attempt to stay put. Again, pretty specialized use case, not something I do all of the time, but it can be helpful to know. But hopefully at least seeing that, even if you don't need to use it in your own projects, hopefully just seeing these crazy different examples helps to show exactly what the texture coordinate is doing. All it's doing is just giving directions to the texture to tell it where to appear on the model, or in this case, a light. But let's go ahead and I'll delete that, turn my rendering collection back on, and let's bring my environment texture back. Okay. And let's go back to our material preview or back to Eevee. The main thing I want you to take away from this video is that if nothing is plugged into this vector slot here, it's going to use UVs by default, even if your object doesn't have UVs. And that might cause some confusion if you're not aware of that. The other thing I want you to remember is how to use box mapping. And that's just by selecting a node here and hitting Control T, setting the texture coordinate to generated or object, and switching the projection method on the texture from flat to box. So that's something that you'll probably want to use all the time, so it's definitely a good one to remember. Okay, and that's all the time we have for this video. Go ahead and try these different texture coordinates out for yourself and play around with box mapping. Try to get different textures mapped to different objects and see how it works. And in the next couple of videos, we'll take a look at how to get more specific with where we want our textures to be on the model with UV mapping.